When you are printing with PLA, air filtration probably isn't something you think very much. But once you start printing materials like ABS or ASA, things become a little bit different. These materials can release volatile organic compounds that we call VOCs and ultrafine particles while printing. And even with an enclosed printer like my Bambu P1S, those emissions can end up in the room. This video is sponsored by BIQU. But because I am going to print ABS, I should dry it first properly. BIQU sent me this unit for review and honest feedback to see how it works with my P1S in real time. The packaging is fairly straightforward. Inside we have the Panda Lungs unit itself and some parts needed to install it on the printer. One thing I noticed that the body of this unit is a fully 3D printed ASA body. You can also see the layer lines. The bottom part is magnetically attached, and in the top part you can see a pre-installed filter media. It has dual layer filtration of HEPA and activated carbon. This cable will be used to power it. Now let's install it on my printer. For installation we need to remove the back panel. I'll show you a safe route for power cable that it won't get in the way of printed. We are going to use this port to send the power here. It fits perfectly on the right corner using adhesive tapes and a screw, which are already included in the box. It has two buttons on the front. One is the main power button and the other one is for fan to turn manually on and off. Also, it has display to show total VOC, temperature and humidity inside the chamber. Now let's bind it with the printer wirelessly so that it can turn automatically on and off. Open your network setting and search for Panda Lungs hotspot network. Enter the password given on the screen. Wait for some time and click open browser and connect for further setup. You can also access this panel using the given IP address below. So Wi-Fi scan has completed now. Select the network on which your printer is connected and enter the password. Then click connect. The Wi-Fi connection is successful now. Now we can move to the binding process. Click binding and scan for the printer. Select your printer. We need access code of the printer to bind. Open your printer screen menu, search for WLAN option. And here you can see the access code. Enter the code and click bind. So now Panda Lungs has been successfully binded to the printer. Go to control panel and you can configure all the settings you want. You can configure filter cycle process here. You can change temperature unit to Fahrenheit or Celsius. There is a threshold value of 0.6. You can see live data of total VOC. There are some air quality related information here. Go to Wi-Fi and IP. You can use this STA IP address to access this web UI on any device within the same local network. Now let's move to the testing part. I'll print this benchy in PLA first. I have this air quality monitor for better readings. I will turn off the fan because PLA doesn't need that much of filtration. You can see the chart I prepared with the readings from my air quality monitor. Even without the Panda Lungs, values are still less than 0.6. That is the safe level provided by BIQU. Now I will print the same model with ABS. That means I need to clean the bed properly with isopropyl alcohol. It is also recommended to use some glue when printing with ABS because ABS can warp very easily to ruin your print. Also, we need to heat the chamber, leaving it for some time so that we can have a baseline value. I have also reduced the speed for ABS to avoid failure. If you want, I can make a separate video about ABS. Just write ABS in the comment. One thing I noticed that the built-in sensor of my Panda Lungs are not that much reliable. I have tested so many times but results are not consistent. That's why I totally depended on my air quality monitor for readings. You can clearly see the difference between Panda on and off readings. And this is the reading of aldehydes and PM2.5 as well. After observing the charts, I can say that Panda Lungs is definitely working, that it is cleaning air. But will it matter to the air in which we are breathing? Let's see. I will run a 5-hour long ABS print to check the air quality outside the printer because we inhale the same air. This time I will put this monitor on the printer. You can clearly see the difference between air quality of the workspace. Without filtration, it crosses the 0.6 threshold value, and with filtration on, it stays in the safe level. So it's time for the result. I know you would have some question in mind like if I can use it without proper ventilation. I want to tell you that ventilation is always recommended when you are printing with ABS, ASA or other engineering materials. I genuinely like this product that it actually works and improves air quality in real time. I like its automated operations like automatic on and off feature. Also, you can check the chamber temperature and humidity. But what I didn't like is you can either use AMS or this Panda Lungs. You'll need a power splitter to use the both devices at the same time. Also, in my case, total VOC sensor readings are not reliable. If you are wondering that if you should buy this or not, I say if you print mostly with PLA, then there is no rush to it. But if you print with ABS, ASA or other engineering materials regularly, it may be an extra protection layer in addition to your proper ventilation. I have attached the link of this product in the description below if you want to give it a try. Many thanks to BIQU for sending me this product. Thanks for watching and see you soon in the next video.